Hopefully my microphone is working. I see my meters dancing around. It looks like the volume's even a little bit better. So I'm not sure what happened towards the end of that meeting. And we've got 10 of you, 15 already in this one. You guys are fast. Nice job. And I'm going to go ahead, because I know I'll forget otherwise, record this. Oh, it is already recording. I had it set to manual. So I'm going to go ahead and jump right into 21, and we'll get these other kiddos hopefully joining. I think we got 12 of the 15. So let's do just that. Scrolling down, doing a new page here, 21. Let's look for a 21. Anybody know which one? There's 21. Right there he is. So the directions say, let f of x be this interesting function, e plus ln of x over x squared. We're asked to find the average rate of change of f from x equal 1 to e. Oops, I gotta mute somebody that's coming in here. There we go. I don't know why sometimes I have it set to where you would join muted, but now we're good. So the average rate of change of f, I'm kind of throwing an idea back at you that that was a preliminary idea to the derivative. And I know that sometimes you guys will see the word average in a problem, and you might immediately think average value of a function. So you would think, you know, integrate a function from a to b and divide by b minus a. But I want you to kind of think about this one just a little differently, because it's rate of change, which if you really look at these four words, that's another way to say the word slope. And I'm not talking about the derivative version of slope. I'm talking about your Algebra 1 pre-algebra version of the word slope, the difference of the y's over the difference of the x's. And that's what this problem's about. And I know you might think, well, God, what the heck is this problem doing in this unit 9? The only really thing that it has going forward is an ln of x. But I want to start kind of laying down some of these ideas that we talked about at the beginning of the year as we move towards the end of the year, so that our review session is going to be full of things like, oh, wait a minute, we didn't see that since August. So I'm able to kind of sprinkle those in now. So if you're wondering, what we're going to be doing here is simply taking the difference of the y. So that would be the function f evaluated at e minus the function evaluated at 1. And of course, you could interchange those. It wouldn't make any difference as long as you're consistent in the bottom and you subtract e minus 1. So now we would have to do a little bit more. We'd have to evaluate these functions. So f of e would be e plus the natural log of e, right? Subtract the quantity, and now we'll plug in 1, and we get e plus the natural log of 1, and all of that would still be over e minus 1, of course. Now when we start to simplify, ln of e is 1, and the ln of 1 is 0, so I don't really need to write anything there. And when we do all of the simplifying at the top, we just see that the e's cancel. And this is our final answer. I know there is no integration involved. Problems like this have an integration approach as well that would give the same answer. But I think in large part, our issue here is twofold. We could not integrate this even if we wanted to. And secondly, I'm not so sure this is the thing that we want to integrate to answer this particular question. So in the AP review portion of the course in April, we're going to see problems on the AP exam that have the word average in them that will allow you two different approaches. But I tend to try to get my kids more comfortable with the 1 over b minus a, average value of a function approach, because A, you're always pretty darn good at it. You guys are very good at it, by the way. And it's just one less thing that you got to juggle, you know, deciding, hey, 2 points or what. So Arbin, you're asking why didn't we use x squared in f of, oh, Arbin, oh my gosh, you are so correct. I like ignored it. This is not the right answer. Oh, I feel terrible. Easy fix, you guys. I am so sorry. Thanks for pointing that out. I was so tied up with that e plus ln of x. So here's what we're going to have. This part here is still correct. When we plugged e in for this x expression, shouldn't we have had that? And then I subtract, let's plug 1 in for all of these x's, then I would get that, and this is still all over e minus 1. Is everybody following that? So when we simplify, we'd still have e plus 1, but see, all of that's over e squared, and then we'd subtract e plus the 0, and that's over 1, and we still have this over e minus 1. So we just have a little bit more that we've got to do here. We're going to have to get a common denominator among this numerator. So I think this question sort of becomes more of an algebraic nightmare than anything else. So this first fraction, e plus 1, it doesn't need really multiplied by anything. But the second fraction, the e, does need to be multiplied by e squared, as does the 1. So I would have minus e cubed, and all of this would be over my denominator of e squared. And then hopefully you're okay if we divide by e minus 1 or multiply by its reciprocal like this. And then what is this going to do? Well, we don't have really anything that simplifies on top. If we want to write it in descending order, I suppose it could look like this, couldn't it? And then the denominator, you could either write it like this, or if you distributed the e cubed, it's a little deceptive. It's easy to think that you'd get e cubed minus e, which might do some canceling, but man, you don't want to do that because you don't want to break apart part of a binomial. So this is probably what you want to go with. And I'll tell you what I'm going to do with this. I'm going to go ahead and use the calculator to verify if that's all right. It'll take me a second because I have to switch what I'm sharing. And more importantly, I am going to forget what I am trying to show you guys. So I'm going to jot this problem down on a piece of paper just real fast. E plus ln x over x squared, and we're talking about 1 to e. All right, so if I new share, let's new share. You're not doing anything. Okay, there you go, new share. Finally behaving. All right, so I'm sharing now. Hopefully you're seeing my calculator. So I'm going to take f of x, and I am going to, wow, God, yeah, do you see what's going on over to the left? It's like, where is my calculator? There it is. It's showing up now. We're going to hit Control Math Template so we can define this thing. And how about we go with a fraction so that we can do e to the first. Anytime you want to just type in e, you can put a little x exponent of 1 in there. So that it's our numerator. The denominator, of course, is x squared. And then if that's now entered, we should be able to do our difference quotient, f of e. And again, if you don't put anything in that box, I'm pretty sure I'm not sure. There we go. Let's just make sure. O minus f of 1 over e minus 1. And is that what we've got? I think it is. It's written very weird. Again, what difference does it make if this thing is in the numerator with a negative exponent? But I think we had ours in the denominator, if I'm not mistaken. And an entire negative had been factored out of that. But I'm pretty sure that that is equivalent. I'm going to check really fast here. Negative. Yeah. Yeah, that looks good. It is the same. So, yeah, definitely. Thanks for pointing that out, Arvin. We would have missed that. I knew we brought you into this class for something, Arvin. Nice job. All right. I don't know if I had missed anything in the chat from our other Zoom session. I think we're caught up to the problems that you guys wanted to see. Anybody else have any of the problems that you want to look at, or you have questions in general? You guys have been doing a pretty good job. Better than I have. I won't make any more mistakes. I'll do my best. Anything at all? Let's look at 22. I think that's on a new page here, if I'm not mistaken. All right. The problem says, find the area of the region bounded by the graphs of the equations. Well, the simple idea of it saying area hopefully triggers the fact that you're going to want to use some integration. So we'll use some definite integration for sure here. This is a very complicated sketch, and my thought process here is to not have you guys have to sketch it to verify what the boundaries are going to be. I will have a hard time doing that, so I don't expect you guys to do that. I just expect you guys to trust the fact that these two values here are going to be the upper and the lower boundary. It would be nice if we knew which one was which one is smaller would serve as our lower boundary, and it probably seems logical that 2 once divided by the square root of 2 is smaller than 2. So here is our approach. This is a good problem. This is a tough one. It's a tough one because we don't see these kinds of forms as often. So strategy-wise, you might be thinking, okay, maybe we could let u be all of the stuff in the radical that's worked before. Well, the problem is the derivative of that is 2 times x. Now, you got to be very open-minded here. This is not an x. And I know you're like, oh, what do you mean it's not an x? It looks like an x. Well, it's an x to the -1 power, right? Because of its location in the denominator. So if this x were up in the numerator, then this would be a straight u substitution approach with the offset of a half. But with that x being down there, we start thinking about, well, wait a minute, isn't this a perfect form for one of our inverse trig functions? And that would be, of course, arcsecant. And at this stage, I'm perfectly okay if you guys just recognize that fact. This is just a 1 over a, which is obviously 1, times the arcsecant of u over a, which is x over 1. I'm just going to leave the x in there. And then we have our boundaries. So the challenge in this question really isn't all of the intense steps of the integration. It's more of just being able to recognize this is the arcsecant form. And yeah, you're right. I do need absolute values around this. I was probably going to wait for somebody to throw that in the chat. But if you didn't put absolute values, I wouldn't deduct anything because you're about to plug in 2 positive numbers anyway. All right, we're going to go ahead and finish this question because of the fact that sometimes dealing with secants and arcsecants can be a little challenging. So you're essentially dealing with this. What is the arcsecant of 2? Wow, that's enough to make you want to lose your lunch. Minus the arcsecant of the 2 over the square root of 2. Well, Guys, I have wonderful news for you. You don't have to do an arcsecant. There's a little trick. Instead of doing arcsecant, we could do arc. Yep, you guessed it. I read your mind. Arc cosine. Do you guys want to predict what we're going to do with the two? Who can be the first to type it in the chat? I bet you know. It's really a matter of who types the fastest. What would we do with that 2 if we use arc cosine? Turn it into a 1/2. Good job, Vince. Good job. And just to kind of verify that to everybody, I'll share my calculator here really fast, and we'll do a little experiment. Let's experiment. Yeah, I love to experiment here. So we'll go arcsecant. Come on. I clicked it. There we go. Arcsecant of 2. I'm going to put a decimal point. So 1.0472. Who would have thought, right? And then we'll compare that to arc cosine of 0.5, which already has our decimal point, and they're the same. So that's a great way that you can kind of get yourself out of a bind when you're dealing with a really nasty inverse trig. Guys, I'm not saying that you're going to see that on the test tomorrow. I do know that I have a really cool TI Inspire activity with optimization of a angle that a soccer ball is supposed to be shot on goal that I'm going to share with you during our review time together. We're going to do the same thing with this guy. He will become square root of 2 over 2. If you're really kind of wise to this, you might come to the realization that the square root of 2 over 2 is the same as 1 over the square root of 2, the non-rationalized version, if that helps you. So now we just have to think about what angle measures produce these. Some of you are better at that than I am. So if we think about what angle measure has a cosine of adjacent over hypotenuse of 1 over 2, this guy's going to be radical 3, like he matters. This is a 60-degree angle, right? So that would be pi over 3. But unfortunately, to do our other, that's a 3. Yep, in some regions of the world, that would be a 3. But not here in Avon. There we go. And then this arc cosine of whatever you want to think, 1 over radical 2 would be fine. Hopefully you guys are thinking that that's a different triangle. What angle here would give us an adjacent over hypotenuse? Well, that would, of course, be a 45-degree angle, aka pi over 4. So then when we not cross multiply, but we get a common denominator, 4 pi over 12. I think we had a problem like this not too long ago that resulted in a similar result. Pi over 12, that's what our area is, pi over 12. I could certainly graph this and do that integration trick in the analyze graph, and you could see what the shape looked like. You could see where the boundaries were in relation to each other, and then it would spit out this area. Of course, this area would be in a decimal form, so you would probably have to go to the scratch pad to figure out what the decimal is for pi over 12, but it's, what, a little bit more than 0.25-ish. So hopefully that helped on number 22, Vince. What else is on your mind? Because we still have, I'm trying to think about when we started this particular Zoom session. It was around, I think it was around 2:28-ish or something like that. So we're halfway in, so we'd have like 40 minutes at least. So I think I'm going to spring for the elite Zoom, so we don't have to mess with this. I hate having to do 2 separate meetings. It's kind of a pain. So maybe I could use money from the IT jar. So more of you need to say it in class. No, I won't do that. I'll write a grant to AEF. Anything else? Okay, looking at 18. Previous page. Previous. All right. Just a straight up definite integral. And we have the luxury of having the quadratic in the bottom with nothing on top, which I hope that that kind of like really gets your mind going and focused on complete the square with this guy. Nothing else that can be done with him. So we've got x squared plus 6x with a little bit of space, and we'll do our three amigos. And we have 6. Oh, I love it when the first amigo is even. Cut him in half, square him. So you'll add 9, only to very soon after, at some stage, subtract 9. And it doesn't really matter what order you write these in. But the key is to keep these 3 together so that you can see the factoring that takes place. And then somehow these will get, whatever order you write them in, you should get a +4. And, you know, if by some chance you had like -4 there, that's a big red flag. That's a big one of these, kids. Yep, because you don't have an inverse trig form that looks like a squared minus u squared, right? Arctan has to have the plus. So that's probably a good indicator that a mistake may have been made. So what else to do with this problem? Well, we can go ahead and identify that a is 2, u is x plus 3. I'm hoping that I'm not bothering anybody by bypassing writing a squared and u squared. I think you guys know those at this point. And I know that some of you, if not all of you, many of you at least, don't write du equal dx when you know it doesn't matter. And that's okay. Won't lose anything for it. So then you think, okay, arctan, does it have a 1 over a? It does. Do we have an offset constant as well? We do not. So we have 1/2 arctan of u over the a. And yep, this is a definite integral. So we have the boundaries -1 all the way down to -3 to worry about. So 1/2 out in front. And then arctan of 2 over 2, which is the same as the arctan of 1, comes next. Subtract. We plug in -3. Woo, we caught a great break there. Arctan of 0. Probably the easiest thing to take the arctangent of. And then we have 1/2 times. And what is the arctangent of 1? I think that's a 45-degree angle, is it not? Think of it like this. Here's your angle. I'm going to call the angle x. If opposite over adjacent is 1 over 1, then that angle measure has to be x. Remember, and I think you know this, if I was your trig teacher and I was teaching you this, I would probably remind you every week, and maybe Mr. Meunier did this anyway, is that anytime that you ask the question, you know, what is the arctan or arcsine or arc whatever, you're wanting to give an angle. I'm asking for an angle. So that angle measure is 45 degrees. And then the arctangent of 0 is 0, if that bothers you. Well, how do we know that? Well, you can unit circle it, yep, but I just like to think of the graph of tangent. You know, we have a 0 there. The tangent of 0 is 0, so that just means the arctangent of 0 has to be 0 as well. So you're looking at pi over 8 here, which just happened to be, I think, an answer off of your quiz. Is that right, on the back side? Probably shouldn't have said that in case there's anybody in the stream here that hasn't taken the quiz, but I think part B was pi over 8 for that particular problem, part B of number 4. So hopefully that helps. I hope that helps. And we'll go ahead and throw it back to you guys to see if there's any other issues here on the review guide that you want to talk about, or feel free if you've got a question that's kind of concerning you dealing with a textbook homework problem. I can call that up really quickly. Open up my PDF. Definitely think that we covered some good stuff. Let me ask you this. In the chat, you don't have to answer. I'd like to have a number of you, if not all 15 of you. That would be great. Give me a scale of 1 to 10, like the anxiety level that you've got about this test. So a 10 would mean that you're really kind of freaking out. You don't feel like you know anything. An 8 might be that you feel like many of these techniques just get away from you and you don't think that you're going to apply the right one. You know, something along the lines of a 2 or a 3, say, hey, I've got the things memorized. I feel like I have a pretty decent confidence level with what to try, and just let the chips fall where they may. So, but yeah, go ahead and put that in the chat at some point, and we can kind of gives me an idea about what you guys feel. If you don't want to answer, because I know you're like, hey, I'm a 1. I'm not going to announce to everybody I'm a 1. Everybody's going to think I'm a nerd, right? Sarah had asked about number 44 in the textbook homework, so I'm going to call that up here real quickly. Calling that up. PDF of textbook 4.6. The natural log function. Open with PDF. Scroll back. Sarah had asked number 44. I sort of remember this problem a little bit. I love these questions where, like, Johnny wrote out this solution and et cetera. What's the error? There aren't very many of these that you see in textbooks. So I've kind of been approached to try to write a bunch of these for some different organizations and reflect like some common mistakes that might be made and so forth. So it's kind of exciting. I threaten to use the mistakes that my students made. Wouldn't that be cool? Would you guys feel that would be demeaning of you? I could even credit you. I would say, hey, so-and-so from my period 5 class made this mistake. So maybe you'd get paid. All right, so let me see. Can I paste? Looking to see if I can paste. Okay, come on, let me paste. I don't want to. Go to my clipboard. Copy the picture. I mean, worst comes to worst, I can save it as an image, and then, because I'm going to have to do that. Well, that's no fun. All right, so let's do that. Let's save as an image. And we got the 10-minute warning here. Save this as an image. It'll probably take me 10 minutes just to take care of this. And I better put this in my desktop, otherwise I won't know where it went. There we go. In all of its glory, there is number 44. I'm just going to kind of put it right on top of those 2 problems, try to make it a little bit less blurry here. The directions for this problem was really cool. It's basically find the error. Find the error. So good question. Yeah, Sarah, this is a really good question. It doesn't look like there is any error, right? You would take the 1 over x and you would integrate it to get natural log absolute value. the boundaries don't change. They don't need to change because of the fact that they were there was no u substitution. We plug in 2, and we plug in -1. Well, of course, the absolute value of -1 is going to be 1. That produces an answer of 0, and we get natural log of 2. But the situation initially, you guys, is right here. What do you notice about the domain of 1 over x? Is there a number for x that will cause this to have issues? And I know you all see it. It's 0. It isn't 0 between these two numbers. In fact, I think that the graph of 1 over x, if I'm not mistaken, it looks like this, doesn't it? So what we're actually trying to do in this problem is integrate from there to here, and we have this like infinite sort of space that we have to contend with when we find area. So this is a problem. It's not something that's impossible to do. It's called an improper integral. And wow, can you read that? Let's write it in English now. It is an improper integral. And basically, it's going to be covered in BC. This is not going to be on your test, you guys. But I love that question because again, it starts to kind of plant that seed a little bit. So, but that's a good question. I'm glad that you guys brought it up. So, all right. Looks like the most common scale of 1 to 10 anxiety is like a 6. 4 and 6 seem to be the most, and that's good, you guys. That makes me feel good. And I think that that's very likely that some of you 6s might be a little bit more nervous than you probably ought to be. I think you're going to be fine. You know, anything that you still are a little bit unsure of as you guys continue to kind of study tonight, or for you lucky ones who aren't taking the test until Wednesday, as you move on as you're studying tomorrow night, just holler at me either through Schoology, or just better yet, hit me up during class or before class, before school, after school. And I know some of you in 7th period have the ability to do SRT on Wednesday as well. But you guys are doing a good job. The fact that you hung out with me for an hour and a half on a rainy Monday that you're out of school, that speaks a lot to me. And I love Zoom. I think that this is the way that we're going to move forward with more of these. And you know, we only have 2 more units left, but if you like this, I don't mind doing a review session before the next 2 exams using Zoom. I don't think we're going to probably have a lot of snow or an occasion to use this on a snow day, but if that were to happen, we'd certainly break Zoom out in those situations. So, all right, hopefully we're good to go. I got 3 o'clock, so I've definitely used enough of your time. So keep studying, and let me know if there's anything that I can help you with. I'm going to get this video archived so I can get it uploaded to Schoology, so our folks that were not able to attend can watch it. So, all right, I mean it. You guys are doing a great job, and I'm really proud of you. All right, I will see you in class this week. Take care and enjoy the rest of your day.